if this is our star, right? Let's see if I can make it a little clearer for you. And that Venus, Earth, Mars, and we've got the Kuiper belt. We've got Jupiter, Saturn, Uranus, and Neptune. We've got Mercury here, and it's moving inward. We've got these three planets, and the faster they go, they're moving outward. Earth, we'll put an E here, a V here, and an M here. It's Venus, Earth, and Mars. And our moon is moving inward. When in pair production completes, then Mars has two very small moons, and if Theia, if my model is correct, and Theia was actually the moon of Mars and it hit us, then Mars's moons are moving this way, while Venus, Earth, and Mars are all moving outward. So we can see that magnetic monopoles are moving inward into the inner solar system, and charged dipoles are moving outward. So if we come out here and we put 95 plus moons around Jupiter, and these are all moving outward. And we know this because Pluto's out here, and along with some other ones that are out in the asteroid belt out here around, or the past Jupiter, Pluto. Then these moons out here, which are charged dipoles, are also moving outward. Right? Pluto's moving outward. It's got a couple of moons, but those would be moving inward. And that means that these outer planets are magnetic dipoles, which we've already discussed. This is an antipole structure there, Jupiter, that is birthing moons, and they're going outwards and flowing this way. So what we see here is that the smaller moons around Jupiter get larger and larger and larger as they're moving out past Pluto, and we get this charged dipole V. Smaller particles getting larger and larger and larger and larger and larger as they move outward. So if you were to take this and set Venus, Earth, and Mars at the end of it over here, you'd get that same V going outward. Mercury is the largest charged monopole. And then it goes down to our moon, a couple small ones here. And out here we've got these small, like Jupiter's, like Pluto's moons, and some other small moons of moons in here. So this is actually going, right? They're getting bigger going this way. And the thing is if you take these and set this out here, Jupiter, and these are negatively charged, centropic charge, or magnetic dipoles. And so you get this V at the beginning of here, and this V from the planets getting larger sets at the end of this. And so what you get is negatively charged particles moving inward, right? And you get positively charged particles moving outward. So let's stop and consider that for just a second. If this is true, and it is, then what is causing the planets to stay in their respective orbits isn't gravitational. It's what's called orbital resonance. And orbital resonance is maintained by the passing of energy and matter inward and outward. So Venus lost its moon, which will cause it to increase in velocity and move slightly outward. Earth has a big moon, right, that it got from Mars. But when Mars's moon hit us and became our moon, it slowed Earth, which means Earth is technically moving slightly inward as it slows. And these two get closer. And the closer they get, pretty soon our moon leaves us and hits Venus. Venus will then slow and start moving back in slightly, and our Earth will accelerate and move outward. Mars's moons are growing, so it will begin to slow and move inward as Earth moves outward, and when they get close enough, Mars's moon will leave it again and come to Earth. So the passing of charge in the form of magnetic monopoles or moons moving inward and out causes the planets to move in and out in their orbital resonance, maintaining their orbits. That is happening here, and it's happening the opposite out here. Since these are negatively charged particles in the star's positive field, then these small charged dipoles are moving outward. Well, I'm sorry about the art. I'm a horrible artist. I'm a theoretical physicist. I don't do art very well. The problem here is, well, it's not a problem. It's a solution. Think about an ice skater extending their arms. They slow down. They pull them in. They go faster. Same thing's happening to the star. The energy being passed in the form of moons inward is accelerating the star, and the outer moons, being charged dipoles with gravity force, they're being sent outward. So the outward motion of the outer moons maintains the orbital resonance of the outer planets. They'll move in slightly and outward slightly, passing moons, until the moons trail off into space. And this slows the star, obviously. It's just that it's that skater. Put your arms out, you slow. Pull them in, you go faster. So the inner planets are sending moons inward in the form of energy as part of its orbital resonance and increasing the speed of the star. So this is a field created by the star, our solar system, that has a natural ability to accelerate and decelerate the star on its own. So what does that mean? Let's be honest. Well, it means that every 11 years, the polarity of our star flips. And what causes that? Well, it's the acceleration of the inner planets fighting the deceleration of the outer planets. And so this acceleration and deceleration has created a very stable, repetitive acceleration and deceleration that causes our star to travel in a slightly helical path. Now, this is why our star isn't just straight. It's slightly going like this. It's accelerating and decelerating a little bit every 11 years. So ask any scientist you've ever heard of, or any scientist watching this, explain to society, to people, why the star flips every 11 years. They still don't know. And I'm telling you, this is what's causing it.